All right, so we are finishing lesson 1 from unit 4. We started it Friday. We pretty much worked on it the entire hour. We just have a little bit to get through, and then you should have time to work on your puzzle piece. Now, how much time all depends on you not talking over me, for example. Because I'm fine with just waiting. Like, I'm not going to waste my breath continuously telling the same people to shut their mouths. It's really annoying, to be honest. So I'll just wait until you're done. And if that means that all your homework you do at home from now on, then that's how it goes. Like, I'm not going to waste my time telling you to be quiet. So that is what we are doing today. My first and third hour really only had like 5 minutes to work on it. So that again is because they would not stop talking over me. We do not have to do things in groups. Like I could have you sit in straight rows, everything independent, all on your own. So if you were absent Friday or any day for that matter, everything's recorded and linked in the slides. So either way, you are responsible for making up or taking the same assessment. So you still have to learn things on your own time for whatever reasons that you are absent, whether it's for a good reason, whether it's for a bad reason, whether it's because you were sick and you couldn't move. Either way, like in order for me to give you credit for the course, you still have to pass the test, right? So just make it up on your own time. I try to make it super easy to stay caught up by making it available online. Not really many other teachers do that still, so you're welcome. The puzzle piece is unit 4, lesson 1. You may have already finished it because it's been available since last week. Otherwise, it's just 5 problems, so make sure you get it done. These are the best way to prepare for the quizzes, which are also the best way to prepare for the tests. I will not be putting this slide in the slideshow anymore, so if you've been needing to resubmit your second binder check for whatever reason, get it done before the end of this month. I will not be reminding you every day. You guys are getting too old to be reminded every day of the same thing. It's already in the grade book. So either you have the 50 assessment points or a portion of it or none of it. You know how it affects your grade. And that's what your grade is before any of the unit 2 stuff has even been entered yet, because I still am grading your retake. So that should hopefully be in the grade book by this Thursday. So I get 7 days to grade stuff. The next assessment will be a quiz. Since we don't have school Friday, we won't get to it this week. It will definitely be sometime next week. You do not. Yep. So you'll know when the quiz is coming up because we haven't set an official date for it. You'll know when we finish lesson 5 because it's over lessons 1 through 5. So any questions on that? All right. So then back to the notes. We're starting out with some definitions. So we're still referencing the notes from Friday, but you have a new note sheet and these definitions are printed on there. It's just a matter of understanding the definition. So if that means you need to rewrite it into your own words, then so be it. But the first definition is dependent variable. It's a variable representing the output of a function. What letter do we usually use for output? Not X, Y. Because if I have an input-output table, which one is normally my input? Which means that Y is normally my good. Now, if you notice, the output or the Y usually depends on the X. That's why Y is the dependent variable, because it depends on something else. Again, if you need to rewrite it in your own words, do so. But here's this example. Y equals 6 minus X defines Y as a function of X. The variable X is the independent variable because you can choose any value for it, right? Normally on input-output tables, you'll see like 1 through 5, for example. Like they just pick whatever they want for the X. For the Y, it depends on what you chose for the X. So like if this is my equation for this table, Y equals 6 minus X, then what's the y when x is 1? So input output table, we're saying that x is 1 and this is my equation. And what is y? 5. Because what's 6 minus 1? And what about when x is 2? What's the y? Good. 6 minus 2 is 4. What about when x is 3? The y is 3. Good. When x is 4. And when x is 5. Good. So it's the y that depends on the x. We usually get to pick whatever we want for the x and so forth. So questions on that? All right, give me examples of things that depend on other things. What was that, Devin? Okay, you on your parents, that's usually what you guys tell them. When I say what depends on what, that's usually what you guys say, but it really could be anything. It could be like the number of sales that a store makes, depends on how many customers they have or how many things that they sold, right? So the dependent variable would be like the number of people that bought ice cream or whatever it is. The independent variable, or sorry, the dependent variable is the sales from that. So independent is the number of people that bought stuff. Dependent is the sale. So that's what it depends on. So then scrolling down to independent variable now. That's a variable representing the input of a function. So independent input, what letter do we usually use for input? X. So independent variables are your X. Usually it's some form of time, but it can be other things. So there you go. And that's the same description as before. We can choose any value for the X or for the independent variable. The Y depends on the X. Questions on that? All right, here's a way that I remember each. So normally you have to graph your independent and your dependent variable. What axis is usually my dependent variable? Well, let's see. For my dependent variable, it usually represents the output. So what axis are my dependent variables on? The y-axis. And the way that I remember that is that out of the y-axis, I can draw a D for dependent. That means that the x-axis are usually my what variables? Independent variables. And guess what? You can make an I with the x-axis. You technically also could with the y-axis, but the y-axis is the only one that you can make a D with. So that's how I remember it. So if you look at the situation from Friday, the dog being tied to a post and like the time that passed and the distance that it is from the post, which one is my independent variable, the time or the distance? Time. One, you know that because it's on the x-axis and x is independent. And also if you use that trick I gave you, that's another way you know. So what's my dependent variable? The distance. So does the time change based on how far the dog is away from the post? No. That's why the time is independent. It's not affected at all by the distance from the post. Questions on that? All right, Adelie, what do you need? Yes. All right, so there's a few examples. Take like 30 seconds, no more than 30 seconds. Give me a few other examples that we could write on our notes to help us remember which one is independent and which one is dependent. So think of some sort of situation, like I already gave you one, which was like number of customers versus sales, right? So that's one example. You within your groups take like 30 seconds to come up with another one. All right, go. Now raise your hand if you can give me a good example or you heard a good example at your table. Remember, the time you get to do your homework in class all depends on your level of participation. Camille?
Number of times takes to sell something, then the number of customers you get, or the number of the money, and the number of how long.
Okay, so let's see, let's kind of alter that, maybe like, let's do like a baking scenario, like cake sold or something like that. So then what would go on the x-axis? In that situation you described, what is independent? So number of cakes, and then what goes on the y-axis? So if you're using customers, then I would actually argue that they should be switched. Because wouldn't like more customers mean that you have to bake more cake? So let's kind of. Maybe if we make the y-axis like number of hours needed to bake. Or something like that. Because if you have more cakes, you need more hours to bake them. Right? Something that depends on something else. What else could we do? Anything? What about something that I usually see as an independent variable is temperature? Can you give me something that depends on the temperature?
Outside. The sun, the weather, the sun.
The sun depends on the temperature, is what you're telling me. Something that depends on the temperature, could be anything almost. Animals doing what? Live, what are they? Hibernating, okay, good. So temperature, and we could do number of animals hibernating. You can even do temperature and like ice cream sales. You can even do temperature and number of sunburns, temperature and rainfall. Anything that depends on temperature, you could put on your y-axis, which is your dependent variable. Good, any questions? All right, so then I'm gonna give you a new situation and it's also written on your notes. So time in seconds since the dog owner left and the total number of times the dog has barked. So in your groups, you're gonna figure out what depends on what. Maybe even fill in the blank for that sentence. Blank is a function of blank, so don't call it out yet, but like, is it barks is a function of time or time is a function of barks? One of the two, figure out which one's right. And then one person from each group will go to whiteboard.fi and sketch a possible graph for the relationship. So kind of like we did just now, you write something on the bottom, something on the y-axis, depending on if it's dependent or independent. And then based on what's going on, sketch a graph, what you think it could be. So questions on that? Everyone know what we're doing? Okay, should not take long at all, because the quicker you go, then the more time you have to practice. So don't just stare at each other. I know you guys are like awkward. Just say hi. Hi, my name is this. Here's my thoughts and answers. All right, give you about 4 minutes. Out of all of these, I guess the group that followed instructions the most would have been this one, because they have their axes labeled. They don't have their tick marks labeled. And then they sketched what they think like as time drags on, it looks like the number of barks kind of increases and decreases. Is that a possibility? Yes. So just consider that if this was a constructed response, you need to have as many parts as you can. So what is independent in this situation, time or the number of barks? So you're saying that the barks determines what time it is? Is that what you're saying? So then what it should be is that the number of barks depends on how much time has passed, right? So dependent on the Y, independent on the X. So if you have time on your X axis, then you're doing good so far. If not, just switch it. This is better than nothing, I've got to say. Some people were struggling what to label. You just have two options. All right. Any function of time, like anything that's usually time related, is usually on your X axis, if that helps at all. So then for the tick marks, what do you think would be a reasonable amount of time to put for your tick marks? What do you want to count by? Maybe 60, like for minutes. This group looks like they counted by 5 seconds. Do you think that that's good? Why not? If you look at what we did Friday, what did they count by? On Friday, they counted by 20s for the seconds. So that's how, because the person, how long did they take usually from running into the store? Just a few minutes, right? So really no more than a few minutes on your X axis. Now, what about the Y axis? What do you think a reasonable number of barks would be to count by? So this one counted by ones. Now, what if the dog barks a lot? Should we have more? And it really just depends on the dog. So like this one might be good, going all the way up to 12. I think no more than like 50, unless that dog is like constantly barking for the entire few minutes that it's outside, then it's not a reasonable amount. Would it be reasonable to count by hundreds on the Y axis? No, because again, that is too large. Now, do you think that we should use a continuous line for this graph? For the most part, that's what you guys are choosing. Can you have a fraction of a second? Can you? Can you have like 5.5 seconds? Yeah, why not? You can have fractions of a second. Can you have a fraction of a bark though? No, what this graph would technically be implying is that, say, like at 13 seconds, there's like 2.5 barks. Does that make sense? You cannot have half a bark. So really, you should not have a continuous graph. You should have a discrete graph, which Camille's group added, erased it. This, if you just take out the lines and keep the red, that would be a good example of a discrete graph. So discrete graphs, and write this down. So maybe for the graphs from Friday, is this continuous or is this discrete? The one from Friday? Is it a continuous line or are they like dots? So the ones we did Friday were all continuous, because can you have a fraction of a second? Can you have a fraction of a foot?
No.
Yeah, why not? The dog was always at least some distance from the post. So that's why it was a continuous line on the situation from Friday. For this one, it'd be best to have dots because you can't have fractions of bark. And the order of your dots depends on what you think is going on. Does that make sense? Any questions? And also label that this is an example of a discrete graph. So what is a function of what? Is it time is a function of barks or barks is a function of time? What depends on what? So barks is a function of time. All right, it's not that time depends on how much the dog barked. That doesn't make sense. So then, is it possible to have like, let me read it, it's on your note sheet. Is it possible that when the number of barks is 6, that it's at the 15-second mark and the 16-second mark? Is that possible? Yes. Because if you're just counting how many barks, it's possible to have the same amount of barks over multiple seconds, right? So if that was an input-output table, it might look something like that. Input of the seconds, number of barks. Are you allowed to have multiple Ys be the same and it still be a function? Yes. Now, can time be a function of the number of barks? Can it be switched? No, because in functions, you're not supposed to have any repeating what? X's. No repeating numbers in the X's spot. So if I made it flipped, all of a sudden it's not a function. All right, questions on this lesson? All right, so just like my other classes, you don't have much time, but you have like 3 solid minutes before you can pack up. So don't waste it. They're really heavy on the academic detentions. I don't know if you've heard of that. But literally, if you're not doing what you're supposed to do in class, the teacher could write you a detention so that you can stay after and do the things that you were supposed to do. So that's something that they're trying to roll out, so just be aware. Do what you're supposed to do in class, so you don't have to come after school unless you want.
Yeah, because you have to do stuff at home.